Good morning, everybody. Thank you very much, Luca, for inviting us, for inviting Bluegame, giving us the honor to open this Congress. I was told to introduce myself, to talk about myself, and it's not easy, at least for me, to do that. So I decided to let pictures talk for me. And so I decided to let them speak, and I'm going to show you the many different boats I've been sailing with and racing with. Practically, I grew up on a sailing boat, starting my really young age, 9 years old. It was my first regatta. The picture you see there, my crew is not a giant. It was me that was very, very small. And you can see from Flying Junior 470, Tornado, Flying Dutchman, Soling, IOR at the time, IMS, J24, the Magus 24. And so I really, 30 years more or less spent on the water. Fighting, competing against the best sailors in the world, but overall learning a lot and learning to face and respect the elements, the sea and the winds. And this is something that will reflect very much in my future, in my activity in this business. In between all of this sailing, including 2 Olympic campaigns in 1988 and 92, which I did sail with 2 different kind of boats. So it was 6-8 years of really hard work to get there, to get the maximum we could from our training. In 1991, I managed to get my PhD in architecture, and thanks God. And so I had the possibility to work in the pleasure yachting. And overall, it was the beginning of the adventure with Bluegame. This is my first yacht that I designed, that I built. At the time, I was still sailing professionally, and the owner of the sailing boat I was sailing was every time asking me, "Look, I would like to do this, I would like to do this, I would like this kind of power boat that is not in the market." And one day I decided, I brought my drawings, and this guy was crazier than me, and he liked the drawings, and overall he let me build the boat. So this is a beautiful 55 feet with which I started my career, and it's 2001, 2002, if I'm not wrong. This is the first day of sailing of the first Bluegame ever built. We are in South Africa, in Cape Town, and it's where the adventure, because it was an adventure, where the adventure of Bluegame started. Here, I really believed I could transfer the concept of Bluegame on bigger yachts. And finally, I had the opportunity in 2015, when I was collaborating with San Lorenzo, to propose to Mr. Perotti this particular boat. He liked it, and it was really a turning point for the company with the beautiful SX88 and 76. And here are the last products of Bluegame with the BGX, the BG74, and the first catamaran we built, the BGM 75. Bluegame and innovation. Honestly, being a no brand when we started, building these power boats in South Africa, we really needed to have something special to be able to sell, to compete, to be on the market. And we entered the market with a real unconventional product. Many people said it was a power boat for sailors, and I was very proud when they were saying that. But you can see for example, the typical walk around, the large swimming platform. And please, these pictures are about 20 years old. So you have to see these images considering 2005, almost 20 years ago. And then, like we normally do when you build a one-off sailing boat, you go to the best naval architect. That's what I did. I went to Washington, D.C. I met Luca, and he spent all the Bluegame so far we did. And I really like to have this picture here. I took personally that picture from Bluegame 60, and that is Bluegame 40. It was transferred from Genoa to Monte Carlo. It was about 35, 40 knots of wind. And we didn't meet anybody out there. Only 2 kites, I remember, in front of Sanremo. So, and this has been a real DNA of our brand. Many people tell me, I was at the Boca, I saw only Bluegame sailing. So I'm really proud of that. When I was talking about respect of the elements, of wind, of seas, this really reflects very much in my boats. As you can see, the mooring areas, the driving, the visibility, the safety when you walk around the boat is all part of that I really feel I could transfer to my production. But I had fun also working inside the boat. When San Lorenzo purchased Bluegame, we had to expand our product range. And so I had to invent something. We could not make a flybridge Bluegame. It would have been the death of the brand and for sure a terrible unsuccess business-wise. So I called Volvo Penta. I asked, how much can I shrink the engine room? And they gave me the minimum length from stern to the first bulkhead. I gave them a little bit more, just a few centimeters more for safety. And I compressed everything in the aft part. But in the meantime, in the platform, there is a big hatch. So when you want to access the engine room, you find plenty of room and possibility to work. This way, we could do something unique that no boat of our range can propose. You can find this in beach areas of 50, 60 meters, not on a 23 meters long boat. So it was a real success for Bluegame. And only a company with our DNA could start such a complicated project like HSV. Okay, HSV was born my dream. Dreaming to have a zero-emission boat sailing at the next America's Cup, and to have a Bluegame, a foiling Bluegame, the first ever foiling Bluegame presented at a fantastic event. But designing and engineering such a complex project needed to find to outsource most of the activities, and that's it was a big part of the project in finding and coordinating this incredible team for the design, for aerodynamics, composite, foils engineering, powertrain, and whatever was part of the design, engineering, and building of the boat. The design was the only part that was done inside Bluegame. It was done by myself and Mirko Prandi. We worked together on this. Practically, we tailor-made the boat around the main systems. I'm talking about the batteries, the fuel cell, and the hydrogen tanks. They were very, very big, especially the fuel cell was something that if you will go to the yard, you will understand, how very little space we left because it was really a huge volume. the hydrodynamic part, we appointed Caponetto and Huber, and on the contrary of what they do with the America's Cup boat and the other boats, these foils and struts were not, they could not design from a clean sheet. There were very strong constraints. Inside the strut, we have the transmission, we have a rod to move the flaps, and we have also the only water intake we have in the boat. So they were really, it was hard work with them because the two things didn't really match. It was much, much easier work on the rudder, which was just, hydrodynamic work. I think they had much more fun in working on the rudder. A composite. Composite is a key figure for key point for the construction of HSV. This boat weight was really, important. So being light, being stiff, being resistant, and so working together with Gurit and with San Giorgio Marine, with Paolo and Edo, was a fantastic team. So on one side, the engineering, on the other side, the building, the construction of the carbon. And many other small parts were then built in composite. I'm talking about, in this picture you see the elevator, the rudder blade, and this is the upper part of the A-frame, which is the system that allows to work with the rudder, to rake and to move the rudder, and the cone, which is part still of the rudder. So thank you to Paolo, thank you to Edo for their fantastic job. Voice engineering. We appointed Schickler and Tagliapietra to work on this part, very complex part, very strategic, very difficult. And as you can see, how many parts, different materials involved, titanium, special stainless steel, and including the rudder. As you can see, it's another very complex part, mixing carbon and metal parts. And Daga and Davide did a fantastic job. Thank you again to them. Here are some pictures of the strut and the torpedo while their process, and the pictures do not do justice to these beautiful parts. They are real masterpiece of craftsmanship, and I really have to thank Gianni Cariboni and Angelo Glisoni for their job. They have been really incredible. Thank you again to all of you. Powertrain. The engine, the motor of HSV is an electric motor, is 220 kilowatt. 220 kilowatt in about 600 diameter by 25 for 85 kilos. So very small machine, very clean, very neat. But I wanted to put this picture on because this is the day we went to do the testing. And I was scared. When I saw, you can see very well, but when I saw all the wiring, electrical wiring, signal wiring, cooling system, I got scared. And, but honestly, it was only aperitif, because when I saw everything which now is inside the boat, this was just a joke. And the power is coming from, the power given to the engine is coming from the 80 kilowatt fuel cell and from the two batteries. So it's symmetric. You have two fuel cells and two batteries, one for each hull. The hydrogen storage is in 2 bottles for each hull again, and we can store about 33 kilos of hydrogen at about 350 bars of pressure. This mechanism there is on both sides, and one is reducing the pressure from 350 bars to 15, and the other one is the one who is speaking with the system controlling the boat. Here is just a detail of the big drawing you saw a few slides before. At the beginning, we thought we could use a standard transmission, Mercury, Yamaha, but my friend Francis was not very happy because the dimension of those transmission were too big. I'm talking millimeters, not centimeters, but it was enough for them. So we started a long battle because on our side we needed room for transmission, ball bearing, bevels, to have all those normal engineering procedures. On the other side, Mario and Francis were asking for a slicker, smoother, finer shape. And so we kept battling. At the end, we found the right compromise. And anyway, we built ourselves the transmission completely. So it's a custom transmission 100%. Mechatronics. Mechatronics is what allows HSV to take off, fly, land. Practically is the control between the hydraulic engine, valve actuators, and giving the right impulse to flap and to the rake of the rudder. Here you see a part of this installed on board. And in the first picture, you see the testing we did at Cariboni factory with all the inverters, the pumps, the tanks, everything. In the third slide, the last one, it's what at the end, we decided. We built 2 cabinets, about 80 times 80, and we stuffed everything in there. So the inverters, the pump, the tank, so we could do all the fitting out outside of the boat. And then we put these 2 blocks inside. And you see at the end how it looks, the forward peak of HSV, which is very small. So we went inside, and it was a way to optimize the fitting out of this system. As we said, the boat is flying, so we need a software controlling the flight. Fabrizio Marabini and Roberto, Riccardo are the guys involved in this. The pilot on HSV does decide the direction, the speed, the height of the boat, but the rest, so the takeoff, the flying, the landing, is all taken care by the software. So today, by the way, we should do the first flying attempt of HSV. So I'm very excited and thrilled. Anyway, I thank Fabrizio. I don't see him, but anyway, thank you very much for all of your support. This is the heart of HSV. The PMS is the system that let fuel cell batteries, pumps, inverters, everything inside the boat to talk to each other and allows the crew to control them. This project was followed by 2 different firms, 3, Italian, Spanish, and Swedish. It was Tesia and Metz actually doing this particular job. As you could see, I guess the project was not so easy. And also, it was not so easy for our technical director, Paolo Dassi, and our project manager, Jacopo Baroni, coordinating different engineers and suppliers from 9 different countries in Europe and also from the United States, because sometimes Mario was in the United States or Davide. So it was a very complicated overall job. The hydrogen. At the moment, there is no harbor in Italy with a permanent filling station. With the help of Nat Power, we managed to pioneer this possibility, the fact to fill hydrogen with HSV. And this is by a truck coming to the private dock of San Lorenzo, and with a dispenser in between the truck and the boat. By difference of pressure, we can fill the tanks. The fact that we don't stock hydrogen, we just have the truck coming and leaving, after the filling operation, gave us the possibility to get all the permission by the La Spezia Harbor entities. I was yesterday at the fire department, so it's not another complex part of the project. And obviously, this underlines how it's so important for the development of this kind of propulsion, the development of a network of filling station in the Mediterranean harbors. And Nat Power, which is investing a lot of money in this operation, helping us, is focused on this particular job. They are not thinking about automotive. They will work only on harbors. And at the next Venice boat show, they will show up for the first time the filling station they're going to do right in Venice. So compliments and congratulations to these young people looking really forward. HSV and industry. This project, as you could imagine, has been a real important investment in terms of money, time, energy. But in the meantime, it helped us to grow, to get new technologies and know-how. This know-how, we are now transferring it to actual production. And we are already working on 2 projects, one for 2025 and one for 2026, in which we will put a lot of this technology inside the models. Here we see BGF-45 is a multi-hull, and it will be semi-foiling, won't be foiling flying like HSV. It will be skimming in the water, and powered by a traditional IPS engine, diesel engine. The fact to use foil will reduce drag about 35%, so we can get better consumption, lower emission, and this is a really fantastic result. But our goal was to have a super comfortable riding. And here you can see the difference between a standard monohull, which is with the blue line, and the BGF-45 with the red line. This is the angle of trim, so it's the angle the boat does when she hits the wave. And we are talking about 30 knots of speed and about 40 centimeters of wave. Why this specific wave situation? I imagine this boat sailing from Monaco to Saint-Tropez, to La Spezia, to Corsica, summertime, beautiful time, but you always have that choppy wind. When you have a sea breeze, you always have choppy. And a monohull tends always to bounce on this wave. So I'm really looking forward to see trial this boat, to use this boat, to propose this boat to our clients, because in my opinion, it's going to be something really new, something new on the market from that point of view. And here, as I was telling, the power curve shows that we can use very small engines to get very good speed. And so it's a combination of results. The second boat we are going to present is a BGM-65 HH. H is for hybrid, because Volvo is going to present, and we will be the first one using it. It's going to present an hybrid diesel electric engine, and the other H is for hydrogen. So we can combine the hybrid situation with hydrogen, and this boat will mount the same fuel cell that you have seen on HSV. We will be able to cruise at 10 knots with about 60 miles of range. 60 miles is from La Spezia to Corsica. So it starts to be an interesting range. We are not talking like we have been talking for years with electric engine to get out of the harbor or maybe sail in a protected area. We're talking that we can sail for a few hours, zero emission. So this is really something new in the market. And here you see the boat itself. Here you have an idea of the two powertrains, standard powertrains. The electric engine is just 30 centimeters longer, so it doesn't make any difference for us. Then you have the two fuel cells, the four bottles, the two batteries, and an emergency genset, a standard diesel genset. And this is showing what I was saying before. So you will go electric up to 10 knots. When you need to go faster, like your car, if you have an hybrid car, the boat will start the engine diesel. I trialed the hybrid solution in Gothenburg, and I can say it was a very, very nice feeling. You really have a smooth passage, exactly like we do in automotive. And from the architecture point of view, there won't be any difference for us because everything will be stored inside the garage. So the two fuel cell on the side and the bottles in the central part where the tender would be. So the only compromise would be to have a tender on the beach area, which is not such a big problem. Foils and industry. I believe, maybe you could feel my enthusiasm or my energy, but I really believe in the development of this technology. Plus now with the progress of materials, of software, of hydrodynamics, I think this will push even more the development of foils, either on sailing than on powerboat. On powerboat, we have just seen what we can get. On sailing, I think there is something that could be really interesting. Looking at the last America's Cup, I think we all were stunned by the performances of this fantastic boat, flying at 40, 50 knots, 35 upwind, was incredible. But my attention went on the fact that these boats were sailing flat. And I think if we can move to a sailing close to zero heeling, it really will change things. 70-80% of the market is powerboat. And people who sail powerboat are really scared to sail, what for us is normality, walking, enjoying a day of sailing with 25 degrees heeling of the boat. For them, is a nightmare. So it's something that, for me, it will be a point to focus for the future. And here you can see the difference. You see a standard boat in maybe 8-10 knots of wind, maybe, heeling almost 20 degrees. On the other side, we have a boat flying 35, and you could cook spaghetti while sailing. That's why people prefer the catamaran when they go charter. But they are not catamaran, they're just moving houses. We have to find a balance between sailing, performance, and comfort. So I do believe that this idea, this feeling I have, could really be a fantastic source for giving more energy to the market of sailing, which is reducing, getting really to a niche of users. I don't think sailing deserves this. I think in a world of sustainability, sailing should be really something pushing hard. So thank you very much. I'm finished.